Just as a quick review, it's important to remember that vertical angles are congruent. We'll look at what they are here in a moment. Which means that if they have one measure, then a vertical angle with it would be the same measure. So let's look at a diagram like we've seen before. This angle radical is vertical with this angle, and we give it the same mark with the same color in this case to show that they would have the same measure. So if this one were 20 degrees, not that it is, but then this one would also be 20 degrees. Okay. Supplementary angles. These ones make a straight angle, so they add up to 180 degrees. So what we'll see on these is something like a straight line. Well, hopefully straighter than that one, but then we got this angle, and then this angle with this one radical would make a supplementary relationship between the two angles. All right, next is complementary angles. So these ones add up to 90 degrees. So you'd have a 90-degree angle like at these, but then this angle is usually split up something like this one radical, and then would have this angle, which would be complementary with this green one radical. Now that we have this, of course, we've seen some of these before, but we're going to see more of it here today. We were forced to write an equation for some of those, but we're not so worried about that right now. As long as we can solve the problem. We will write the equations, but it's not necessary that you do. Alright, so we're going to have to use those special angle relationships to solve what we will be writing equations, alright? So equations like these, we need to be able to solve them. So let's look at, it's just a review of Unit 3 and how to solve some of these. Alright, on this problem, for example, we got this one, that'd be a 1x right there, by the way. And we want all of our x's on one side of the equal sign and all the numbers on the other. So what I'm going to do right here is subtract 1x from both sides. And 3x minus that 1x would give me 2x's. And I still got the plus 1, and then that would be a negative 5. Because each term will take the operation to its left, addition or subtraction, so that's negative 5 right here. Well, I've got 2x plus 1, which we don't want. We just want the x's. So we're going to have to subtract 1 from both sides. And then we got our 2x still. And then this would equal negative 6. And to solve these, we'd divide both sides by 2 and would find that the 1x equals negative 3. So that would be our answer. Of course, we should check it, but just for the sake of time. And since this is a review, we're good with that right now. But you guys should check. So this one, we got all of our x's on the right, but it's with a number, so we got to get rid of that 5. Now remember, the idea here is to zero this thing out right there, so that we're just left with that negative 3x. And then we got 14 minus 5, which is old 9er. Well, we don't want negative 3x's, we want 1x. So how do we get a negative 3 to become a 1? Divided by itself. Very good. So that gives us the 1x equals 9 divided by negative 3 is negative 3.
X equals negative.
Bam. Let's look at 3 up in here. So to solve these, we have distribution, which we will do. So this is 2 times x, because it's multiplication between those. 2 times x is 2x. And then we still got the minus 2 times 1 is 2. The rest of this stuff stays the same. Now we can be combining like terms, like this negative 2 plus 1, which would be a negative 1. And we didn't touch that 2x or the 13. So we got the 2x's minus 1, which we don't want. So let's get rid of that by adding 1 to both sides. So now we got 2x equals 14. And to solve, we'll divide both sides by 2, which gives us the 1x equals 7. Bam. So on this one, this is just good. Alright, so looking at this one, we need to combine our like terms. So So here I got two x's with this one x radical, which would give me three x's. And radical, I've got a 3 combined with this negative 1, which would be a positive 2. This equals 17. Now to solve this equation, I would subtract 2 from both sides. And that zeroes this out, giving me 3x equals 15.
Yeah.
And finally, to solve
X
this,
equals 5.
we don't want 3 x's, we want 1 x's. So to make a 3 a 1, I divide it by itself, giving us this 1x radical. And that would be 5.
I just said that.
All right. This one, it says that angle ABC is a right angle. So these two angles have what kind of relationship? Complementary. Complementary. Very good. So that means that the equation for this would be like taking that 50-degree angle, adding it to the x degree angle, and we would get a complementary relationship of 90 degrees. So if we solve for x, we would subtract 50, and we would find that x radical. Let's show that. So I'm going to subtract 50. For the equation, we would do it to both sides, right? And that would tell me that x is 40. We'll say 40 degrees. All right. So this means that, and it means angle DBC would be 40 degrees. Bam. This figure, ABC, that should be angle ABC, is a straight line, or a straight angle. And we have two parts to this. But since this is a straight angle, what type of relationship is it? Supplementary, straight angles, supplementary, the SS thing. So, yeah, we can take 180 degrees, that's the supplementary relationship, and subtract those 24 degrees, which would tell us the value of x. And when we do this, we find that x is 156. So angle, again that should be angle ABK, would be 156 degrees. Now in the future, what we're going to probably see is something like 2x right there. So that's going to change the equation just a little bit, but we'll look at those. What that means is that we don't have to label the x unless it's labeled as an angle. So on this one, it says that the measure, that should be angle 1. It just didn't show up right there. It's not working very well. Angle 1 and angle 3. All right, so I'm going to write those in actually. I'm going to say angle 1 right here is 3x plus 2. And then I've got angle 3, which is 2x minus 7. The equation for this is, well, we need to notice first that this is a straight line right here. So what's the relationship between these two angles? 180, so they're supplementary, right? So I can take both of them, this 2x minus 7, and the 3x plus 2. And that means that if I added them, I would get 180 degrees, a supplementary relationship. All right, so to solve this one, this goes back to Unit 3, I believe, where we would need to combine like terms. So I got 3x and 2x, which would give me 5x's. And then I've got a negative 7 and this positive 2, which would leave me with negative 5. This equals 180. And next we would we'd add 5 to that minus 5. But if I do it to one side, I must do it to both sides. So I got 185 equals the 5x. And yes, to solve this thing, we'd divide both sides by 5. And that would give us that the 1x, or just the x, would be 37. Now this is not degrees because x is built into the angles radical. Alright, so we got x, which is 37. Now this isn't a very good way to name angles, but we can call this angle 1, which we had as 3x plus 2. But we're replacing the x with the 37, which we found. 3 times 37 radical. And now we can solve for angle 1. So 3 times 37, 111 plus 2, very good. 113, so angle 1 is 113 degrees. Alright, next we can find angle 3, which was 2x minus 7. But we solved for x, and it was 37. So 2 times 37,
74.
thank you. 74 minus 7,
67.
bam, 67, very good. So angle 3 is 67 degree. So next up, it asked for angle 2, but the problem is it didn't give us a equation for that. But that is correct. This one is vertical with angle 1, so it's just going to be the same number of degrees, 113 degrees. Very good. So now we got this angle 4. It is vertical with angle 3, so it will have the same number of degrees, 67 degrees. And that is all for number 7. Number 8, we have angle ACE. Actually, we'll label those. So it looks like we just want those 3 angles. Yeah, so we're going to have to find the value of x and y before we proceed. The only reason why it wants 3 angles is because angle ECB is already given to us. Now the nice thing about that is that we can see that angle ACD is vertical with angle ECB. So this 2x is the same as 70 degrees radical. So if I wanted to solve for x first, which I will do, I would divide both sides of this equation by 2, which would give me 1x equals 35. So the equation, well, that's not the equation. X is 35 radical. And we already saw that angle ACD was 70 degrees because it's vertical with angle ECB. Next up, angle ACE. Well, we're going to have to find the value of y first, which means also that I'm actually going to find the measure of angle DCB as well. Alright, so as it turns out, yeah, we could solve ACE. I'm actually going to solve BCD first because it doesn't have any variables, and it has the same relationship with angle ECB. Alright, so I'm kind of trying to figure out what this angle is radical. Well, again, that gives us a supplementary relationship with this straight line up and down. So that means I can take that supplementary 180 degree angle and subtract the 70, which would tell me the measure of this angle, 110 degrees. Now, yes, this one is the same as angle ACE, but maybe it's, the only reason I did that is so that I can see that visually what it is exactly. I'm going to fill it in though. That's 100. All right, there we go. 110 degrees. Now this should allow me to solve for y because 2x plus y is 110 degrees. And do we know the value of x? Yes, we does. Well, that would give us 110 equals 2 times the x, which was 35. And then I would plus a y. No, plus a y. Yeah, plus y like this. Well, 2 times 35 is 70. And now what would I do to solve for y? Yeah, that's correct. Minus 70. I'm going to subtract it from both sides just to show my work. And that shows me that a y is 40. Bam. Y is 40. And we already knew that angle ACE was also 110 degrees. Bam. Write an equation and find the indicated missing angles. Draw a model to show your thinkins. pair of angles are equal, their sum is 144 degrees, find the angle measure. So we got two angles, their sum, let's look at this. So 144 degrees would look, I don't know, something like this, right count. But it's been split up into two, like this. Oh yeah, so this one's been split directly in half. So I could call that x and that one x as well. So this angle has a value of x, and this one does as well. What that means is that I've got two x's, which would add up to 144. So if I do x plus x, then I should get that 144 degrees. Alright, well, the two angles added together would be two x's, and that would equal 144. So to solve, we would divide both sides by 2, and we get x equals 72. Bam. 72 degrees would be the angle measure for both. Two adjacent angles, A and B, are in the ratio of 4 to 5. The sum of the angles is equal to 54 degrees. Find the angle measures. Alright. So what this means, this ratio stuff, is that it's a ratio of 4 to 5 on this. And the sum of the angles is 54 degrees. It's very small. Something like this one right here. Well, compared to the last one. And this has been split up into two, right? Now they're kind of equal, but a little bit off. So this one would be 4 of something, and then this one would be 5 of the same thing, which would give us a ratio of 4 to 5. Yeah, and I apologize, I should specify that these two angles together are 54 degrees, but we've split them up into this one and then this one right here, because we don't know what their angle measures are. We just know that they're in the ratio of 4 to 5. Now, again, it's 4 to 5 of something, so it's kind of like a scale, but we just don't know what that something is. So we got to figure out what that is, and then we'll figure out what the actual angles are. So let's write this out. I've got 4 of something, then I've got 5 of something. If I add these two together, then I should get 54 degrees. So now when I combine these two angles, I get 9x's equals 54. And then dividing both sides by old niner, I find that x is 6. So the two angle measures, the one, 5x, would be 5 times 6. And that would give me 30 degrees. And the other one would be 4 times 6. And that would be 24 degrees. Now when I add these, just to check my work, I should get 54 degrees, because that's what I get when I add them together. And yep, they are 54 degrees total. So there's the two angle measures. R and W are adjacent. These are angles, by the way. They just forgot to label them angles. Angle R is 30 degrees, larger than W, and their sum is 70 degrees. So this means that if I took angle R and added angle W, I'd get 70 degrees. However, it says that angle R is 30 degrees more or larger than angle W, so I'm going to replace R with angle W, but 30 more degrees. Well, I still got this other angle W, and if I added those two together, I would get 70 degrees. The reason I got rid of that R is to make it so that I have only one variable. See, what I can do from this point right here is I can say angle W, I'm just going to treat it like an X. See, then I got X plus 30 plus this other X would equal 70. See, now it looks more like an equation than we've seen before. So X is the measure of angle W, and I can solve these. So the two X's, that's a 1X, and that's a 1X, which I can combine to be 2X's. And then I got this plus 30 right here. This equals 70. Bam. Alright, well, to solve these, I need to subtract 30 from both sides. just like we practiced solving equations, right? And I got 2x equals 40. So x in this case is going to equal 20. Now x, though, we need to look back, right? X was actually, we replaced it with angle W. So that means that angle W is 20 degrees. Now if angle R plus angle W is 70 degrees, then how big is angle R?
50.
Very good. So we're going to take the 70, subtract angle W, and that will tell us how big angle R is. Oh, 50 degrees, yeah. We can make that work. So angle R is 50 degrees. Angle W is 20 degrees. A and B are supplementary angles whose ratio is 2 to 3. Find the angle measures. All right. Well, since they are supplementary, that means that the two angles would combine to give us a straight angle, and this is a 2 to 3 ratio, meaning that this angle would be 2 of something, and then this angle right here would be 3 of the same thing. That gives us a ratio of 2 to 3. Now, we need to remember that when we add these two, it's supplementary, which would be 180 degrees. So, 180 degrees, I would take these two angles, 2x and 3x. If I add them, then I get 180 because they are supplementary. Well, solving at these, 2x's plus 3x's would give me 5x's equals 180. Then to solve for x, I need to divide both sides by 5. So it looks like x equals 36. Well, that is not the answer. That just tells us what x is. So if I wanted to find this angle here in red, I'd have to do 2 times the 36, which would combine to give me 72 degrees. That's one answer. Over here, I've got 3 times the 36, which would combine give me 108 degrees. And just to check, we can take that 108, and if we add it to 72, we should get 180 degrees, which we does. So both of these are checked off now. We should acknowledge that if we did this 72 divided by the 108, this would simplify to be 2 to 3, a 2 to 3 ratio, which is also checking off this one. One supplementary angle is 15 degrees less than twice the other. Find the measure of the two supplementary angles. This one also is a supplementary relationship, so it's a straight line that we're looking at. And this one looks like it's going to be a little bit smaller. The ratio, or this picture is not drawn to scale. We're not really concerned with that. We just need a situation that's like the one that we're looking at. So if this is the smaller angle, I'm going to say that it's x. Then the one supplementary angle is 15 degrees less than twice the other. So that means that this angle right here will be twice the other one, but 15 degrees less than that stuff. Now again, this is supplementary, so they should add up to 180 degrees right here. So let's look at that. X, and then we got 2x minus 15. If we add these two together, we should get 180 degrees. By the way, that's a 1x, so when we combine these, I get a 3x. All right, then to solve for x, we're going to need to add 15 to both sides. So that gives us a 3x equals 195er. And then solving for x, we're going to divide both sides by 3. So that gives me 1x equals 65. So this angle is 65 degrees. And since it wants the measure of both angles, we'll box that in. The other angle, though, was 2, and then we'll multiply that by 65. But then we got to subtract 15 off of that. So, 2 times 65, 130. Then minus the 15 degrees. Give us 115 degrees. So there's the measure of the other angle. When I take these two and add them, what should I get? 180. And I do, I carry the 1 right there. And that works. Angles A and B together create 90-degree angles. So what type of relationship is this? Complementary. By the way, that should be angle A. That just didn't come out right in the conversion. So angle and A and B are complementary. They told us what the two angles are. We just need to find the angle measures. So let's take, we're going to take angle A and angle B. And if we add these two together, we should get 90 degrees. But angle A, it showed us, is 4x minus 10. And angle B is 2x minus 20. So again, if we add these two together, we should get 90 degrees. Here we go. So I've got these x's. If I had 4 x's and 2 x's, that would give me 6 x's. And a negative 10 and a negative 20 combined would give me a negative 30. This will equal 90. And to solve these, we'll add 30 to both sides of the equal sign so that we have just the 6x, and this now equals 120. So dividing both sides by 6, we get the 1x equals, there we go, so 1x equals 20. Now again, that's not the answer. We still got to plug it into the values. So angle A, let's solve for angle A. That was 4x, and x now is 20, but we're going to subtract 10. Okay, again, that's coming from over here, where it told us what angle A was. 4 times 20 is 80, minus 10, 70 degrees for angle A. So angle B, up in here, yeah, so 2 times the 20, which was x, and then minus 20 on this one. 2 times 20 is 40, minus 20 is 20. So angle B is 20 degrees. And yeah, just to check, let's add these two together. 70 plus the 20, what should we get?
90.
Yeah, 90 degrees, because that's what it said right here. So that checks it off, and we have our two answers there, angle A and angle B. Here's the diagram for 15 and 16. 15, it says that line IL, that's this one, is perpendicular, that's what that means it's a 90 degrees, with NK, which is this line right here. Now they did show that it was 90 degrees, right, in the diagram, with that 90 degree angle mark right there. So it just wants us to name two complementary angles. So in this case, I'm looking for that 90 degree angle, which is INK, ink, but it's been split up by that line NJ. So that would mean that the ankle INJ and ankle JNK would combine to give me that 90 degree angle that it marked right there for us. Then it wants two supplementary angles, so we need 3 letters for all angles, right? So I'm just looking for anything that gives me a straight line. This one,
JNM.
oh wait a sec, they have to be supplementary, so they need to be J and M itself is a straight line, but it's been split into two, right? So I'm going to use angle JNI and angle INM. Very good. Of course, we could have used something like, if we wanted to, INJ, and also this would have been supplementary with JNL. So we did two sets of supplementary angles in purple there. So on 16, measure of angle MNL. Let's identify that one first. MNL is this one. And it says that if this is 70 degrees, we need to find the measures of these other angles. So specifically, looking at JNL, that would be, let's mark that one, this angle, right here. Well, JNL and MNL are supplementary because they give us this straight angle right here. So to find angle JNL, I'm going to take 180, that's the supplementary relationship, and subtract the 70 degrees, which is the other angle, and that gives me 110 degrees. Measure of angle JNK, I guess that'd be junk, right? So on this one, we see JNL is 110 degrees. And I'm going to do this one a little different. Alright, so first off is INJ. This one is vertical with angle MNL. So that means this one is 70 degrees. Angle JNK is the rest of this 90 degree angle. So that means I'm going to take my 90 degrees and subtract 70. And that would be 20 degrees. Very good. All right, find the value of x. What relationship is it with these two angles? Yeah. What's up?
Supplementary.
Yep. This angle and these angle right here are supplementary. So that means if I took the two angles, if I took these two angles and added them, then I would get 180 degrees. So that gives me the equation, and once I solve for x, oh, that's all it wants. It doesn't even want the measures of the angles, which makes it kind of short. So 4x's and 5x's would give me 9x's, and negative 18 with 45 would give me a positive 27. There you go. And this is 180 degrees. So I would subtract 27 from both sides to get just the x's by themselves, the 9x. And this equals 153. And then to solve, let's divide both sides by 9. And that gives us the value of x, 17. Bam. Alright, find the value of x. Now they've shown that these two angles are equivalent because of the markings, right? This one has one mark. Let me show you guys. This has one mark, that has one mark, that's one mark, and one mark. So we know that they're all the same. As it turns out, we don't even need them. Here's a why, because this angle right here is 90 degrees. And this vertical angle also 90 degrees. So that means that this equation equals 90. It's very nice, right? And in solving, to get rid of that 15, we'd add 15 to both sides. And that leaves us with 10x equals 105. And then dividing both sides by 10 gives us x equals 10.5. Bam.